And we have a disk which is experiencing two forces acting on it, and we want to calculate the net torque acting on this disk about the axis. So it's providing us the pivot point that we want to be using in this particular example. So our object in this process is the disk. All right, so let's draw an extended free body diagram of that disk. We're going to take that disk and we're going to squish it flat so that it's a single line. And I'm going to put it vertically because I want to represent my two forces acting sort of in the representation that I see the picture. So there's my disk. I have one force that's acting on this end, happens to be perpendicular with a force of 30 newtons. And then I have a force acting on this end at a magnitude of 20 newtons. So those are my two forces acting on my free body diagram. Now, the net torque, just like the net force, is simply the sum of all of the torques acting on the object. So, if I have the sum of all the forces, all the torques, every force has the potential to exert a torque. And so we're going to number our forces and then determine the torque acting on the object by each one of those forces. So my force 1 will be the torque acting on by force 1. That's going to equal the force by 1 times the radius of 1 times the sine of the angle 1. Similarly, torque 2 is going to equal force 2, radius 2, sine of angle 2. So what do those look like? All right, well, we need to identify the pivot point. And in this example, it was given for us about the axis. So that was right in the middle. So this is our radius 2. And this is our radius 1. To find the angle, we extend the radius, curl to the force. So that'd be like this. And that will be theta 2. And similarly, we extend the radius, curl to the force. Oops, one is blue. Curl to the force, and that will be theta 1. So there's our extended free body diagram with the radii and the theta. And now we can look at the individual torques that each force exerts and subsequently the net torque. So force number 1 is 20. The radius, well, it's half of the axis, so that is 0.4 centimeters. Nope, sorry, that's 4 centimeters. So half of it's 2 centimeters, which is 0.02 meters if we keep our units, times the sine of the angle. Now my angle is 90 degrees. It's in the counterclockwise direction, so it is a positive 90 degrees. Similarly, well, let's calculate that out. I'm running out of room. Usually I like to put it here at the end and then add them on the bottom, but since I'm running out of room, we'll just calculate this value. So we have 20 times 0.02 times the sine of 90. So 20 times 0.02 times the sine of 90. The sine of 90, of course, is 1. So we get 0.4 Newton meters for the torque exerted by force number 1. Force number 2 is the force, 30, times the radius, 0.02, again, half the diameter that's provided, times the sine of the angle, and this is a 90-degree angle, and it is in the counterclockwise direction, so it is negative 90. So we have 30 times 0.02 times the sine of negative 90, which gives us negative 0.6 Newton meters. Now, before we do our summation, let's just make sure that we are in the right direction. So, force number 1 gave us a torque that was positive. Indeed, if this was the only force acting on the disk, it would rotate it in the counterclockwise direction. We expect that to be positive. It is. Similarly, force number 2 gives us a torque that's negative. If this were the only force acting on the object, we would expect it to rotate in the clockwise direction, giving us a negative torque. So our expectations are founded. All right, the net torque is simply torque 1 plus torque 2, so it's all the torques added together, which gives us 0.4 plus negative 0.6. So our net torque is negative 0.2 Newton meters. So determining the torque by every force acting on the object, identifying the pivot point. In this case, it wanted to know the net torque about that pivot point. And once we've identified that pivot point, we can calculate the torque of every force about that pivot point and add those torques together. So that's it for net torque. Just add them up. All right, good job.